Okay, so in this section, we will try to talk about the complex numbers in polar form and De Moivre's theorem. Okay, so first we will plug the complex number in the complex plane, find the absolute value, write complement of numbers in polar form, and do all these things. Okay. So what is a complex plane? So it's like rectangular system. Instead of x and y axis, we would call it what? Real axis and what? Imaginary axis. So z equal to what? A plus bi, because complex number is what? A plus bi. So a is your real and bi, that's your what? Imaginary part. Okay. So what will be complex number look like? It's more like a point. So this is A is your x coordinate, B is your y coordinate. Okay, so because complex numbers is like a point, so you cannot compare two complex numbers. Okay, so points, you can see one point is above the other point. One point is to the right of the other point, but you cannot see one point is bigger than the other point, yeah? So you cannot compare two complex numbers, okay? So this is one common thing that you need to be careful, okay? So then, we wanted to plot 2 plus 3i. So what will be the point? 2, 3, yeah? So then 2, 3. The same as real number line, yeah? Similarly, -3, -5. So -3 goes with what? -5 is right here, huh? And then -4, if g equal to -4, what happened? Here is g equal to -4, -3 minus 5i, yeah? Okay, so -4 we have already done it too. Okay, so -i, then this means what? 0 minus I. So your x is what? 0, y is -i. Right here, yeah? Okay, so then the next thing we wanted to talk about is the absolute value of the complex number. So what is the absolute value of the complex number? Is what? Square root of a square plus b square. What does this remind you? It's the Pythagorean theorem, yeah? So this is your hypotenuse. So what will be the absolute value? It means what? The distance between 0 and this point, yeah? So that is called the absolute value of the complex number. It's almost like what? The distance of this segment, okay? Okay. So then, you do some example. So what is your A here? A is 5, B is what? 12, yeah? So what will you have? Square root of 5 square plus 12 square. 5 square is what? 25, 144, 169, square root 13. So pretty straightforward. Okay, so 2 minus 3i. So what is your A? A is 2. B is what? -3. But be careful, when 2 square is 4. What is -3 square? It's positive 9. Okay, so it's positive 9 because -3 square equal to -3 times -3. Negative sign goes away, so it's positive 9. So many students forget this is positive, they make a mistake. Okay. Okay, so the next thing we wanted to introduce is the polar form of the complex number. So g equal to a plus bi, yeah, so you said to be what? Rectangular form. Okay, so, and we wanted to write as what? R cosine theta plus I times I sine theta. That will be the polar form. It looks like have nothing to be related, but do you remember? A is your what? X coordinate. B is your what? Y coordinate. And do you also remember what is X? R cosine, yeah? And what is Y? R sine, yeah? Yeah, so this is what? No, nothing new, okay? So because we have already learned the polar coordinates, yeah? So x equal to r cosine, y equal to r sine. And A and B is actually your what? X and y coordinate, okay? So this is where this thing come from, okay? Okay, so, so this is this one, yeah? So, and then we know that R, and where is R come from? R is what? It used to be what? The polar, direct segment distance, yeah? So it's square root of a squared plus b squared. And tangent theta equal to b over a. That's also, from what? The polar coordinates, yeah? A is x, y squared, no? Okay, good. Okay, so plot the complex number, then write the number in the polar form. Okay, so what should we do here? So negative 1 minus I squared to 3. So, that's your A, this is your B. A is what? Negative 1. B is what? Negative 3. That's your x coordinate, y coordinate, yeah? Okay, so you can write here. Okay, and then how could you find the polar form? What is R, guys? Okay, R equal to what? Square root of a squared plus what? B squared. Then it's square root of negative 1 squared plus 1 negative square root of 3 squared. Square root of 1 plus 3, 4 is what? 2. Okay, so the tricky thing is theta. So what will be tangent theta equal to? Is what? B over A, yeah? B over A. So it's negative square root of 3 over negative 1. That's what? Square root of 3. But be careful here. This is the tricky part because the point is in quadrant what? 3. Yeah. So what is the reference angle here? Tangent is pi over 3. Yeah. So what will be the theta? Because it is in quadrant what? 3. Yeah. Theta has to be what? Pi plus the reference. So is what? 4 pi over 3. This is the K. This is the K. This is why they wanted you to plot the complex number in the complex plane first, and then write the number. When you plot, you determine which quadrant is this thing in, and then you find the theta. Okay, you find the theta. It didn't emphasize here, but you guys need to be careful. Okay. Okay, so after you find theta equal to pi over 4 pi over 3, then it's very easy because you find r equal to 2, theta equal to this, so then plug it in, you can write it like this. Okay. Okay, so the next one is what will be the product of two complex numbers? So g1, g2. So what will you do? Equal to cosine theta. So what do you say? It will be what? The multiplication multiply r and angles. Okay, so this is how you remember. But how could you deduce it? So g1 times g2. What does this thing equal to? r1, r2. That's easy, yeah? So you have cosine theta 1 plus I theta sine theta 1 times cosine theta 2 plus what? I sine theta 2. Okay? Okay, so it's r1, r2. What happens here? You FOIL. It's cosine theta 1, cosine theta 2 plus I sine theta 1, cosine theta 2 plus I cosine theta 1, sine theta 2 plus what? I square sine theta 1, sine theta 2. Do you guys remember what is I square? Negative 1, yeah? So it's r1, r2, okay? So although it looks complicated, but it's actually not. Cosine theta 1, cosine theta 2 minus what? Sine theta 1, sine theta 2. Then you have I in common. You have sine theta 1, cosine theta 2, plus cosine theta 1, sine theta 2. You with me? So this is, and what do you notice this? What do you guys notice this? That is your sum and difference formula, which I always tell you these are super important. Cosine, cosine together, that's what? Cosine. And then what will you do? Theta 1, theta 2. Whatever, it will be the opposite, yeah? Minus, it will be plus. Sine, cosine, it will be what? Sine. So it will be theta 1, theta 2 here. You will keep the sign in between. Yeah, so this is where it comes from. Okay, but how you remember it? It will be what? Multiply the r and the angles. Okay, this is how you remember it. Okay, so then if you have g1, g2, what will you do? You multiply the r, and angle. Okay, so what will you have? g1, g2, 30 cosine 60 plus I sine 60. Yeah? And because 60 is a special angle, you can even simplify. It will be 30. What is cosine 60? A half plus I squared to 3 over 2. Then when you have 15 plus 15 squared to 3i. We can even simplify. Yeah? So, you know. So because this is we didn't follow the instruction, yeah. So we want to leave the answer in the polar form. This is what we wanted to leave. But if they wanted you to calculate what is this complex number, then you can directly calculate it. Okay, not for this question. Okay, we did some work which is too much. Okay, so g1, g2. So what will you have here? g1 over g2. It's simple. You have r1 over r2. Yeah. So then you have cosine theta 1 plus I sine theta 1, cosine theta 2 plus I sine theta 2. What should we do to get this? Okay, so how could you get rid of the I on the denominator? Do you remember? In chord algebra, always multiply its what? Conjugate. Okay, so then what will you get? So then this will be what? A squared plus b squared, yeah? So it will be what? Cosine squared theta 2 plus what? Sine squared theta 2. What will you do? You do exactly the same thing as before. FOIL. I will not write it because I do not have enough space. And cosine squared plus sine squared is what? 1. And then on the top you have what? Cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Okay, you still have r1 over r2 in front. Okay, so which will be the formula. Okay, so this is where you get the quotient of two complex numbers. Okay, good. Okay, so what will you do for the division? Yeah, so what will you do? You divide r, subtract angles. This is how you remember. So you divide the r, subtract the angle 50 divide 5, you get what? 10. 50 divided 5, directly get 10. Okay, so 4 pi over 3 minus pi over 3, that get a pi. That's all you need to do. Okay, it's pretty Good. Yeah. So then powers. Okay, so powers means multiplication, multiplication, multiplication again and again. Yeah. Okay, so g of n powers, what happens here? It will be r times r times r times r. What will you get? Multiply. Yeah. So because you multiply, so it will be r to the n. At theta, what will you do with the theta? You add. Yeah, you add the angles again. So when you add all these things, it's what? N theta. Yeah, so this is what you get from there. So j to the n is what? R to the n cosine n theta sine n theta. It's a special form of the multiplication. Okay, so this is this one thing. To the 5 is 2 to the 5 at 5 multiply the theta, yeah? 32, 150, 150, yeah? And this you wanted the form in the what? Rectangular form. Then this means you can simplify. It's negative square root of 3 over 2 because this is what? Second quadrant. Quadrant 2, cosine negative, sine is still positive, so you have this. Perfect. Good. Okay, the more words theorem. Okay, so what will you do with this one? Okay, so this is a little bit trickier, so you guys need to remember this. Okay, so if you wanted to find the nth root of this, yeah, so it will be nth root of the r, and cosine, what will you get? Theta plus 2 pi k over n. It's not only theta divided by n anymore. It's theta plus 2 pi k divided by n. Okay, and what is k? Because you have how many roots? N roots. Okay, so you have to have n values for k. So what will you have? 0, 1, 2, until n minus 1. Okay, so if n equal to 4, yeah, so find the fourth root. What will be k? Then k will be equal to 0, 1, 2, and what? 3 is the last one because you have 4 different values here. Okay, this is one very, very important. Do not forget, the values, okay? Okay, so then, this is how you find it, okay? So 16, what will you do? Okay, so then fourth root, what will you do is, it doesn't look good. Here. Okay, so insert a blank page. Let's write it down. So what do we have? We have j equal to what? 16 cosine of 60 degrees plus what? I sine of 60 degrees, yeah? So what do we want? The fourth root. Okay, the fourth root. This means how many do you have? 4. Okay, so what will be the jk? jk equal to what? Fourth root of 16. What do you have? Cosine. Do not forget, it's 60 degrees plus k times what? 360, because you have this, yeah, divided by 4 plus I sine what? 60 degrees plus 2 pi k is 360 degrees times k over 4. Yeah, so then what should we do? Simplify it a little bit. 2 cosine, and you have 60 plus 360 degrees k 4 plus I sine 60 plus 360 degrees k over 4, yeah? So what will be k equal to? 0, 1, 2, 3, yeah? So when k equal to 0, what will be your theta 1? What will be your theta 1? 0 is gone, yeah? So it's 15 degrees. When k equal to 1, your theta 2 will be 60 plus 300, 60 plus 360 over 4. So that is 105 degrees when k equal to 2. So theta 2 equal to what? 60 degrees plus 720 over 4. Yeah. So what it will be? 195 degrees, yeah? When k equal to 3, theta 3 equal to 60 plus this over 4. Okay, so it's what? 285 degrees. What happens? Then you plug it in. Then your G1, that will be 2 cosine 15 degrees plus I sine 15 degrees. Are you with me? G2, use this angle. G3, you use this angle. G4, you use this angle. I will not write down, all these things anymore, but this is the idea. Are you with me? This is how you do it, okay? So the book has, like all these things, all these different things too, okay? So it has, the final answer is the same thing, okay? Okay, so that's the end of this